So thanks for having me, and I'm glad to be here. And I'm going to talk a little today about doing some artificial intelligence with images. So I'm Doug. I'm talking to you today from the United Kingdom. So I'm in about 2 hours out of London, and I do freelance developer relations. I help people figure out how to talk to developer communities, and then I also do a lot of performance work on the web and with native apps. I do performance workshops on images, video, and on machine learning, like I'm going to do today. If you have any questions, feel free to just shout out. If you're on the Twitch, I guess you can chat there, and we can talk about them afterwards. But if you have any questions, feel free to reach out. I'm on Twitter. That's my email, all that good stuff. So images. If you think about building a web page, images dominate the web. Most of the web is built up of images. This is 10,000 random web pages from last year. And you can see that most of the web pages are over 50% kilobytes in images. And the ones that aren't 50% are really, really close to 50%. So when you think about, well, let's make our web page faster, what can we do to make our web page faster? If you can make the images smaller, you can reduce a lot of the tonnage, which will make your web page faster. When you think about taking pictures for the web, the idea is you're out there taking photographs that you're going to then put up on your website. And if you're a photographer, maybe you are doing that. You may just be doing Google image searches to find the right images. And then once you've got all of them, your images, you pop them into Photoshop, you optimize them, you get them onto your web page. All right, it's pretty straightforward sort of practice there. What I have found is that no one likes this step. The Photoshop step just kind of sucks, and no one really wants to do it. And so any shortcut people can find to skip this step, they will do that. What I found is that often results in really, really large images that is going to make your web page slower. I actually wrote a blog post a couple of months ago now analyzing web pages that had images with the term COVID in it. And what I discovered was if the web page was a COVID-related site, generally the images were optimized well and done right. But if it was an image that somebody decided to put on the web page in response to the pandemic that we're in, odds are the image wasn't optimized, and it was a lot larger than it needed to be. It was actually slowing down the web page. And so there's a lot of research that is showing that when you just slap a new image onto the web page, you're sometimes bypassing all of the steps to make sure those images are optimized. Here's a screenshot from Wes Boss saying, a year and a half ago, taking a screenshot is not a good way to save a photo. Around that same time, I noticed that there were a lot of people, this is from Web Page Test, and you can see from the file name that if you use a Mac, you'll recognize this format, screenshot year, month, day, at time. This is a web page where they got the image all perfect on their computer and they took a screenshot rather than saving it in Photoshop or doing any of the optimization techniques that they might do. They just took a screenshot, and that got me thinking. And so I looked in the HTTP archive, and the HTTP archive is 5 million web pages. I found 426,000 images on the web, with a regex for screenshot. Most of them are PNGs, and if you think about that, that's because the Mac format for screenshot is a PNG. There are a few JPEGs. I don't really know what a PHP image is, but there were some. But these are screenshots that made it up on the web. It was on 100,000 websites had screenshots, right? So, 4 per web page, I guess, on average. But if you think about it, there are 5 million websites in this database that I was testing. And what that means is that 2% of the web has a screenshot on its website, right? 2% of the web had a developer or someone who was building for the web page take a screenshot and go take the photo and then put it on the website. I did some analysis, and I took 3,000 of them. I turned them into a JPEG. I did a little optimization to them, and I found that I could make 35% of the images that I studied 10% of the original size, right? So a really, really huge savings. I could make 86% of them half the original size. Huge potential savings. If you're taking screenshots, do a little optimization, turn it into a JPEG, do a little bit of a quality optimization, make them smaller. So like, are there shortcuts for image prep, right? We hate these steps. What can we do? So like, what if I wanted to crop this image? This is the image that's on my webpage, right? I just want to crop it around me. There are a lot of tools that will do that. There's a tool called Cloudinary, and it does a really cool thing. You can say, do a crop and set it 1,000 by 1,000, and you get an image that looks like that. I'm also doing some optimization stuff, a little out of the scope of this, but I'm optimizing the quality and optimizing the format. All right. That's awesome. I've got a shortcut, right? I can crop these images and it's always going to look great until I get an image like this, right? Because the way this cropping works is it does a center crop. And if I crop through the center, like, that's not so great. So you want to do a little bit, to be a little bit smarter. You could do it manually, but manually is kind of what we're trying to avoid. It's not really a shortcut. So one thing that actually Cloudinary does is it has a gravity auto command. And what that does is it finds the most important part of the image. So it's using some AI, some machine learning to find out, you know, what in general is the most important part of the image. And luckily faces tend to be the most important part of the image. So luckily my face was considered to be the most important part of the image. But you can also see that it cropped it nicely around the Swiss flag. So it's actually, it's a pretty nice looking picture, and it was done automatically. So now I have something that will automatically crop around the face and be 1,000 by 1,000. We're looking good. Like, I'm happy with this. This is good. This is done in production. A lot of web pages are starting to do this automatically. This is a picture I took about a year ago. I went to, this is in Poland. These are the bunkers that Hitler lived in during World War II. And it's, you know, it's a one-story building with 15 meters of concrete on top of it. It's a pretty boring photograph. And when I put it on Twitter, Twitter was super smart, and it cropped it around the door. It found the most interesting part of the image and did a crop around it. It focuses on people first and then building second. Like, they have a whole blog post about it. You can Google it. The link is there at the bottom. But, you know, Twitter is doing this sort of finding the most important part of the image and cropping it. And it leads to a better experience most of the time. Sometimes it does some pretty weird cropping, and you've probably seen that if you scroll up and down on your Twitter feed. But in this one, it did a really good job. Other tools that will do this, you know, there's a lot of libraries out there that'll help you with this. This is Image AI, which I found online. They have a blog post on how to, you can see the link here, how to train your AI with 6 lines of code. I think I have 7 here, so I did it wrong. But you get the idea, right? It's in Python, it's based on TensorFlow. It's got a model library, and so here I'm using the ResNet library, and I say, here's an image I have of a town in England. Find everything interesting in it, and it does. And so you can see it'll actually draw boxes with a couple more lines of Python. You can draw the boxes around everything in the image. One thing I didn't even notice in this image was that there's a clock, until the AI found the clock on top of this church tower here. But you can see it's finding people in the purple on both sides of the street. It's finding cars. Right? It's really cool. It's finding all these things in the image automatically. It's identifying objects in the image. Super cool. Here you can see it found the clock, and it's 54% sure that it is a clock. And here's a bounding box, X, Y, X, Y, where you can find the clock up here. You can see it found a bus. It's 84% sure it found a bus, and there's the bus. You know, it's found a lot of cars. Some of the cars it's really sure about, like 98, 99%. Some of them it's not so sure about, 55, 56%, and that's because it's wrong. It thinks this like sidewalk divider thing here is a car. And also there was something, oh, there's another one over here. There's a sign that it thought was a car. So, you know, with the percentiles and the confidence intervals, you can decide where you have your confidence cutoff, and you can say, well, maybe if I only look for cars that that the algorithm is 71%, 80% or more sure, then we'll make sure we always find cars or people. It doesn't find all the people, like these people are too bunched up, so it can't find them. But, I'm really happy with this. Like, this was really cool and eye-opening to me that, with just like 6 lines of code in a library, like, bam, I'm doing object detection in images. So that's super cool. What can you do with object detection? Well, we talked a little bit about cropping, right? You can find the most important part of the image. You can crop the image. And if you're building a web page, you can do fun things like people on mobile are always in portrait mode. People on desktops are in landscape mode. Maybe you crop it differently depending on, the size of the screen. So you can do different cropping depending on the different types of screens that people will consume your content on. And that's kind of cool. Google Maps does a lot of blurring. So why would you blur an object? So here they're blurring out all the license plates so that, for people's privacy. Object removal. So you can remove objects from images. And in this case, this is actually a really funny picture. This is in Munich, and they had enough pictures of this square to be able to remove this tourist, I'm assuming, from the image, except for his or her boots. Right, so these boots are stuck, and they couldn't remove that because they didn't have images of the cobblestones under the feet. But you can remove objects from that. We'll talk about that here in a little bit as well. You can do some cool things like alternative text creation. So for example, in this one, this is a picture of me at a llama farm. And as you can see, it found me and it found 2 dogs. So with machine learning, it works really, really well when the library is trained on the things you're looking for. And so in this case, this library had not been trained to know what a llama was. And so, just like any toddler might do, it said, doggy. They're not doggies. So if the object isn't modeled, it doesn't do a very good job, but it's really, really sure that those are doggies. 88 and 97% sure that those are doggies. So you can try a new library. There's actually an open source tool called llama.vision. It's really cool. It's a PWA that you can run on your phone. I don't have it installed on, I just got a new phone, so I don't think I have it installed anymore, but it's a lot of fun. You should check it out. It's open source. And the library that it's using is really, really comprehensive. So I created an iguana vision, right? The same type of app, but just looking for iguanas. And so you can see here I am running it on my phone. I took a picture of this slide and like, oh my gosh, it's a llama. It actually found out there's a llama. So that was really cool. So using machine learning and detecting objects can be kind of complicated. And so this is one of those classic photos of, is it a duck or is it a rabbit? And I'm going to come over here to Twitter. And this tweet is awesome. Make this video bigger. But he's spinning this picture, and so now it's seeing duck in every degree. Now it's seeing rabbit, and now it's seeing rabbit. And then there's a point in the middle where it sees a little bit of both. So it doesn't see anything here. Now it sees duck. And then right here it sees duck and rabbit at the same time. Duck, rabbit, duck, rabbit. So every degree he turned it, he looked to see, is it a duck or is it a rabbit? And so it's really interesting. Most of the time it is seeing rabbit. Well, it sees duck a lot too, I guess. It sees a lot of duck, it sees a lot of rabbit. So it's kind of fun. You can go through all the other data as well. It's in the link, I think, to the tweet, and the tweet is in the slides, which I'll share later. But you can also see it sees like the peace symbol at some point because of the 2 fingers pointing upwards. Like it sees all sorts of neat things with pretty low confidence, but it's fun to look through that data. So you can detect these objects, and what can you do with these in production? Well, Facebook actually does this in production. They're building their alt text based on things that they identify, right? So this is a picture that a friend of mine was on holiday, and if you look in the Facebook source, it says this image may contain bridge, sky, tree, outdoor, water, and nature. It's kind of a crappy alt text, to be honest, right? It's not really describing what the image is. It's just describing like stuff in the picture. But it's obviously using machine learning to do that. It's figuring out what's in the image and then making that the alt text. Here's another example where it says image might contain dog. Again, kind of useless because there's two dogs, and like the image may contain is kind of like, we're not sure, and so if we're wrong, like don't sue us or whatever. But this is sort of what's happening now. This is live on Facebook today. You can only imagine it's going to get better and be cooler and as time goes on. So you can also train a model. Like, so these were all with pre-trained models, right, to find things in images. And I thought, while I was writing this talk, I was doing a rope climbing course. I pulled my phone out as I'm way up in the trees, and I put my finger over the lens. And I was like, well, that'd be kind of cool if I trained a model to automatically crop this out. Like if it detected it, just remove that from the image. And so Google has an object detection. Well, everybody does. Like Azure has one, and AWS has one. I use Google's because when you upload all the images, you have to give XY coordinates of the object that you're looking for. And the Google one was really easy. I could just draw a box. I could upload the image and draw the box. So it would collect the XY coordinates of the bounding boxes for me. So this is my dog, Max. I walked around taking pictures of things with my finger over the lens for a couple of days to build up a basis of my images. I also downloaded a few off the internet, like this one and that one, right? And so I ended up with like 35 images that I trained my model with, and 43 images, excuse me. And what you can see is I'm getting an average precision of 94%. And so my precision is 5 out of 6 times it's right. The recall is how often it found an object, and how often it missed a prediction. It's wrong 1/6 of the time here as well. And so basically, when you're training a model, it has your analysis set and a test set. And with such a small number, there were only 6 files in my test set, which is why it's always 1/6 off. But you know, I'm really happy with this. This is my first time ever training a model. Not a lot of images, and it just worked. And so I deployed my model, and with a little bit of Python, I can base64 encode the image, send it up to Google. It'll find the box and send it back to me and tell me where these things are. All right, cool. So I upload the image, and I get bounding boxes back. Like it found a finger, it's 99% sure, and this is XY. In this case, Y is 0, XY, right? And there it is. And so then with a little bit more Python, I can say, do I want to crop it vertically, right? Do I want to just cut out a side of the image, or do I want to cut out the top of the image? Do a little math, and I cut out the vertical side, and I've got a really nice image here, right? So now I've got a tool that will automatically crop images if it finds a finger in it. And that's kind of cool. That's fun. I wanted to go a little better. Inside Python, there is a library, OpenCV, that does inpainting. And what the idea behind inpainting is you mask it, and then it tries to redraw the image based on the pixels around the outside of it. And there's 2 models. There's the blurry model and the smeary model. This is the smeary model, and that's the blurry model. So like, we're not there yet. This isn't going to work really well, but I was trying to play with it to see if I could like remove the finger and still make it look like a cool image. It doesn't work on images like this. It does work really, really well on single color areas, right? So here it's a blue sky. I put my finger over the lens. I do the inpainting, and like, my finger is gone. It's awesome. However, it didn't do a very good job down here at the bottom. And the problem is, of course, it's using a rectangle. So even though the shape I'm trying to get rid of is curved, it ends up taking out the clock tower. So that was unfortunate. I started playing around with this, like trying to trick the system by messing around with the borders and removing the outlier. So this is the border. And so what the inpainting does is it picks the border, it smears the colors from the border into the middle, right? So that's why you get these weird smears from the buildings, all right? So like, what if I can remove those outlier colors and just go with blue? So I converted to grayscale, so I only have 256 colors to deal with. I try to bucket the colors and remove all the colors that are outliers, find the most common ones, remove all the other ones, do a little bit of Python here. This is all up on GitHub as well if you're really interested in all this. And it's better. It's still not perfect. This is one of those things that if I had more time and more patience, I could probably make this image look a lot better with the in-painting and improve the in-painting algorithm. Yeah, it's a project. Definitely what I did was an improvement over what the original algorithm did. All right. While I was working on that, I was approached by someone who was interested in doing like superimposing the, so when you buy sunglasses, right, the hardest thing is, does it look good on my face? And there's so many companies selling sunglasses online, but like, how do you know if these sunglasses are going to look really good on my face? You know, when I go sunglasses shopping, I'm usually with one of my kids and they just like, no dad, no dad, no dad. And it takes like years before I can find sunglasses. Right. So, but this is a website, they want to have a try on thing where the sunglasses would be superimposed on a picture that somebody uploads and it looks awesome. And so people could virtually try on their sunglasses, something like this. All right. So, you know, a couple of years ago, what they would have done is they would have hired a couple college students, said, welcome to our company. We're here, excited to have you here for the summer. Here's your computer, here's Photoshop, and now edit 1,000 images and get rid of that and make it look good so that we can superimpose it. But we're going to use computer modeling to do it for us automatically. So the idea here is to get the sunglasses and put it on my face. But obviously this isn't going to work because it's a JPEG, it's not transparent. There's a white background, right? We needed to clean up a whole bunch of stuff here to get it to look like this. First thing is to remove the background. There are a lot of tools out there. There's like remove.bg. There are a lot of APIs out there that will remove the background from your image. It'll save it as a PNG, which has an alpha channel. Maybe even WebP now that is supported in Safari. So it removes the background from your image. So now we're all white. All the white has disappeared. And now I have it superimposed on my face, but it still looks weird because it's not transparent. And you can still see like the arms of the sunglasses, and it just looks weird. Like I would buy sunglasses from this webpage. So I use Cloudinary in this case to remove the background. When you upload the image, you just tell it to remove the background, and it does it. The next thing I can do is you can make the image transparent, and in this case I made it 30% transparent, 70% opaque, and if you look carefully you can now see my eyes are peeking through, right? I made it a PNG, so it does have the alpha channel. Like, we're making progress here. This looks really, really good. Again, the arms. So the next bit is we're going to train a model to get rid of those arms of the sunglasses. Remember, when I'm training that model on Google, I have to draw a box. And when I was drawing just one box, I end up ticking the frame on the outside. And when you tick the frame, you get the in-painting, which does weird things. So what I found is if I drew 3 boxes, a box here around the temple bit, a box around the arm, and then a box around the tip, I did this for a bunch of sunglasses that I found on the internet. And I want to minimize that frame capture because when I do this, the in-painting goes really sideways and it doesn't look good. So when I did this, this worked really, really well. I did this for like 35 pairs of sunglasses. So again, like when I first started thinking about this, I thought I'm gonna have to do this for like hundreds and hundreds. You hear about these libraries that have hundreds and hundreds of images. And I think that's because a lot of those libraries are like, this is a Chihuahua versus this is a Saint Bernard versus this is a Greyhound, right? You have to have different images for each type of dog. In this case, it's like arms of sunglasses, so you don't need a huge library. Like this is pretty easy to train the model on. The thing that I had the hardest trouble with this is that when you do like 40 of these, you start getting a little sloppy with drawing the boxes because you're like, I've been doing this for 20 minutes and this is really boring. So if you're really careful with drawing the boxes, the data you get out is a lot better. I had to do it a couple times to make sure I drew the boxes really, really well. So the first thing that my model does is I send the image to Google, it finds the arms. And then if it finds an odd number, it fails. And so like Ray-Bans are my nemesis because Ray-Ban actually has this text written on the lens and it causes my model to fail. Right. And it sometimes also misses one. So like if there's an odd number, I know that there's going to be manual work afterwards because it only found 5 of the 6 bits here. Or, if it's an odd number, I just know it didn't work right. But if it does find those, I can remove them. I can just make it white. And then I can do inpainting and fill it in. Right. And so this is one of those things like inpainting works really good if it's just one color. These sunglasses, you can tell, aren't exactly one color, but we're going to just like smear it. It sort of just looks like somebody with greasy fingers was touching the sunglasses. But if we make it smaller, nobody actually notices. So what we could do is now put all of this together. Now, when somebody uploads an image of themselves, you would imagine it's always a picture that's like a portrait of them, but it doesn't have to be, right? People do weird things like this. They may not do a portrait of them. They may do a picture like this, right? Where they're off to the side. So what we need to do is we need to crop it around the person's face, right? So I'm doing a crop around the face. I'm making it 1500 by 1500. Then I take the pair of sunglasses, and this is a pair of sunglasses from a web page, right? And then I just remove the background. I make them a little bit transparent so that like my eyes will bleed through a little bit. And then the next bit I'm doing is a little bit of magic here where I'm using an API called, I can't put my mouse down in the corner because you get the buttons, but there's an advanced faces API that looks for the eyes. And so then I can apply this layer automatically just through URLs to sit on top of the eyes of the image. So I crop around my face, right? I center it, and then I remove the background. I run it through the API to remove the arms, and then I can put it on my face. And like this is one that I actually ran. I said, I ran all this as just Python code, and it actually works. And that was really exciting to me because this is, using machine learning and artificial intelligence to create a product that can actually be used in production, which was really, I thought that was a lot of fun. And so that's sort of the story of how I've used some machine learning to play around with images and learn kind of the capabilities around machine learning and artificial intelligence in manipulating images and to create a product, right? So I was able to take a regular pair of sunglasses or an image of a regular pair of sunglasses, remove the arms, make it transparent, put it on my face and come up with this. So that was kind of fun and exciting. And so with that, this is still pretty early. Like Twitter and Facebook are launching stuff, but there are a lot of really neat ideas that you can come up with to do some of these fun things by identifying objects in images and then manipulating them. Like with cropping, blurring, object removal, or creating alt text for your web pages. And so with that, thanks so much for listening and coming out on a Tuesday night. And if you have any questions, I'm here and happy to take them.
Hey Doug, thank you for going us with all the steps that you have used while developing the models and training the models. It is indeed a really highly informative talk, which anyone can easily follow if they are getting started with machine learning and using Python code.
Cool.
Yeah. So if I have to ask, so if someone is starting newly, what would you suggest them? Where what resources they can use to get started?
Great question. You know, I would say the object detection library I used at the beginning, it's called Image AI, and they have a Medium article here. And in the article, they promise that there's a new library coming out. I haven't actually followed up on it to see if they have a new one that's even better. But you know, look at these guys' code. Like it's 6 lines of Python code. You don't even really have to be a Python developer to make it work, and it just does. So that's really exciting. And then I would say there's some really neat stuff now with like pulling words, right? Identifying words or identifying text, or and it sort of depends what you want to do. If you want to learn more about the machine learning, you can go and train the models like I spoke about. But if you really just want to use the tools, right? These are APIs now, essentially, right? You can use these as APIs to get the information you want and use those. You know, if you're just building a web page and you want to identify the car in the image, use this as an API, and then you can center it around the car.
Yep. Cool. Thanks, Doug.
Yeah.
Thank you for going over all the information and sharing us with the resources.
Of course. Well, thanks for the invite. And, you know, if anyone does have any questions, just feel free to reach out.